Good morning. Today we are working on CO56. I can use the Pythagorean theorem. This is a term that you will use on and on and on throughout math. Pythagorean theorem is a big one. Say it with me. Pythagorean theorem. Pythagorean theorem. Pythagorean theorem. Yeah, it's a big one. Let's learn what it means because we're going to have to use this all the time. Liv.
Can I just say Peter?
No, because when you get into geometry, you need to know it's the Pythagorean theorem. Pythagorean theorem. So I always try to put an M at the end instead of an M. An N. I always say Pythagorean theorem, but it's Pythagorean theorem. Pythagorean. Okay. Down. No. We have to know it's Pythagorean theorem. So, listening so we learn what it is. One of the oldest and most famous formulas in mathematics is the Pythagorean theorem. Pythagoras is the mathematician that figured out this theorem. Yeah. Old guy. Its use is traced all the way back to 1900 BC, before Jesus. But it is named after Pythagoras, a teacher and philosopher from around 500 BC. So the Pythagorean theorem is used to find an unknown side length in a right triangle. So we talked about finding the unknown angle lengths. Now we're going to find an unknown side length, but it only works with what kind of triangle? What did I just read? A right triangle. So it only works with the right triangles. What I'm telling you, you will use this in your math career. Everybody will use this going forward. So first, it's important to know the parts of that right triangle. So we have, here is our right angle. The two sides that connect to make the right angle, we're calling A and B. Those are known as the legs. It's the two sides that form the right angle. So that's important to know. A and B make our right angle. C is the side that's directly across from that right angle. The C is called the hypotenuse. So we have a leg, and across from that right angle is the hypotenuse. The hypotenuse is always across from that right angle. That is C. It's important that we know we're going to use those same letters, A, B, and C. A and C form our A and B form that right angle. C is across from the right angle. And it's always the longest side. When we have a right angle, that hypotenuse is always going to be that longest side. So here is our theorem. You're going to be putting this on your help sheet. You can put A and B are our legs. C is the hypotenuse. Our theorem is A squared plus B squared equals C squared. A squared plus B squared equals C squared. Everybody needs to write that down. Super important. A squared plus B squared equals C squared. Mm-hmm.
That's going to be super hard to remember this.
Some of us have heard it before.
Yeah.
A squared plus B squared equals C squared. Now we're going to understand what it all means. Okay? So I'm glad some of us are like, oh, hey, wait a minute. No, I had an introduction to this. We're going to actually use it. Madison.
In our further math career, are we going to be using like C plus D and like it'll equal E?
You'll be using variety of variables,
Okay.
but you will learn other theorems. You will be learning other theorems. We're focused today just on the Pythagorean theorem, but you will learn other ones in geometry, most definitely. A squared plus B squared equals C squared. So let's see how that works. So I'm going to move this up. So we know A squared plus B squared equals C squared. A and B are the legs that make the right angle. So if I look at my first example that has the sides 5, 3, and 4, what are my A and B going to be? Marina, how do you know that it would be 3 and 4 are my sides, my legs? Those are the two sides that are making up that right angle. It doesn't matter if I call this one A or that one A. We know they're A and B. They're the two legs. So you're going to want to label your triangle to help you keep it straight. Where are my A and B? It's going to be the two legs. So now I need to find out what's my C. What's my hypotenuse? Madeline?
5.
How do we know for a fact that it's going to be 5?
Because it's across.
It's straight across from the right angle. The hypotenuse, the C, is always across from the right angle. Always, always, always. So now I'm going to say, does this theorem work? Does A squared plus B squared equal C squared? So I'm going to put it in. 3 squared plus 4 squared equals 5 squared. Is that true? Let's check and see. What is 3 squared? Oh, it is not 6. We do not do 3 times 2. When we are squaring, it's the number times itself. 3 times 3 is 9. What is 4 squared? 16. 4 times 4 is 16. What is 5 squared? 25. 5 times 5 is 25. So does 9 plus 16 equal 25? 9 plus 16 is 25. 25 does equal 25. It works for this triangle. Let's check it again with a different triangle and see if it really does work every single time. So let's look at our other one. We have 25, 24, and 7. What are my two legs? Melanie. 7 and 24. How do you know that those are my two legs, Melanie? They are the two lines that connect for my right angle. So that is my A and my B. What is my hypotenuse? Ava.
25.
How do you know that is the hypotenuse?
Because it's straight across from the right angle.
It's directly across from the right angle. So I know that has to be my C. The hypotenuse is always the C. So now I'm going to put it in to my equation, my theorem, that equation. A squared, so 7 squared, plus B squared, 24 squared, equals C squared, 25 squared. So let's do the math and see if it works. What is 7 squared?
49.
49. 7 times 7 is 49. What is 24 squared?
576.
Is it really?
Yep.
That one I don't have memorized, so I'm going to just double check you. Very good, Dom. 576. What is 25 squared?
625.
Very good. So now we're going to say, is 49 plus 56, what does that equal? 49 plus 576 equals 625. 625 does equal 625. I did my math correct. So when you are doing this on the test, you actually want to do everything. I didn't guess. I used the calculator. I made sure 49 plus 576 really does equal 625. I found it on the calculator. I made sure I did my math correctly. That is my way of checking my work. So you truly want to take that extra minute, 30 seconds, didn't take me that long. Take that extra time to make sure you're doing your math correctly. So we're going to use the Pythagorean theorem to solve for the hypotenuse. So remember, we're solving for the hypotenuse, which is the C. All three of these are right angles. Two of them tell us where that right angle is. The other one, we have to look at it. The direction said it's a right angle, so we know there's a right angle in there. We have to look and say, can I find it? Which angle looks like it's the right angle, Madison?
At the bottom.
Where the 8 and the 15 meet? Yeah. So they didn't give us the box, but the direction said there's a right angle. It's obvious that this one would be the right angle because that's smaller than 90 and that's smaller than 90. So if the directions tell us there's a right angle, then we can say, okay, we know it's a right angle even though they didn't put the square in there. So if we know where the right angles are, can we find our two legs? Yeah, the two legs are where it meets for that right angle. A squared plus B squared equals C squared. So the C will be here. So how do we do this? Up on top, we had all three numbers, but now I need to find a number. So how do you think I do this, Melanie? How do you know the 132?
I mean 13 squared.
How do you know the 13?
Because 25 plus 144 equals 169, and 169 divided by 13 is 13.
Okay, so I'm going to show the math that you did in a slightly different way so it makes a little more sense. So you're doing the right math. I'm just going to explain it a little different. So we know A squared plus B squared equals C squared. So Melanie said 5 times 5 is 25. 12 times 12, 12 squared is 144. That equals my C squared. 25 plus 144 is what, Melanie? 169 equals C squared. I don't want C squared. I want it just to be C. What is the opposite operation of squaring? Oh, was that you, Cam? No. Who said square root? Was that you? That was you? Somebody said square root. I heard it.
Yeah. No, not me. I say that.
Yeah, but yeah, raise your hand if you said square root. Madison and I both heard it. I'm not hearing crazy things. Madison heard it too. The opposite of squaring we multiply. The opposite is the square root, which is a form of dividing, but it's a specific dividing. So remember we saw on our calculators how to find that square root. So if we look at our calculator, I'm just going to erase on the top so I don't have all the pretty colors over it. All right, if we have 169 And we want to find that square root. So we know that this is our exponents button. And right above it, you can't see it very well on my calculator, but we have that square root symbol. The square root symbol looks like this. I'm going to take 169 and I'm going to find that square root. So we're looking for this symbol. The way we find the square root of 169 is I'm going to do my shift button to get what was on there. Oops, I have to clear out what I had. Oh, we do 169 and then the square root. Nope. 100, the square root. Oh, sorry. It's too dark over here for me to see. It's the one that's above the squared button. Because this square root, there's a little number up there. That's why I don't want that one, because that one has the little number. It's the one that's right above the square button is the square root. So I want that one, 169, and I get 13. So look again. Madeline, can you turn on that other light for me? I'm going to see if I can get a little bit more light over here. Okay. So we can see it a little better now. So on your calculator, above x squared, you see the square root symbol, which looks like this, right? So you see that square root symbol. So you do second, and then where that square root symbol is, right above this x squared, then you type in your number, 169, and you hit equal. The way to double check it is to say, does 13 times 13 equal 169? It does. So the square root of 169 is 13. So C equals 13. You see how we got that? Kind of. So C will be 13 because C squared is 169. Melanie knew 13 times 13 equals 169, but you're not always going to know what that square root is. So this is how we find it on the calculator. Let's look at our second one. What are my two legs? What are my A and my B? Layla? Yeah, 8 and 15, because that is where the right angle is. So I know A squared plus B squared. So 8 squared plus B squared equals C squared. Because my C is that hypotenuse. The hypotenuse is always across from the right angle. That's my unknown side. Melanie? Yes. Okay, so hold on. Let me write that out. 8 squared is 64 plus 15 squared, which is 225. That equals C squared. So my next step is writing out what those squares are. Now, Melanie said, I'm going to actually add these two together. 64 plus 225 was what, Melanie? 289 equals C squared. But I don't want C squared, I want just C. So in order to get rid of that square, I have to do the opposite. Remember, opposite operations. The opposite of finding a square of a number is to find the square root. So I'm going to take the square root and I get square root of c squared is c. The square root of 289 is what? How did you find that? By putting it into your calculator, right? We put in let me move it up so we can see. We want to get that square root button. So I do second square root of 289, and I find that it equals 17. Okay, this is not a PO because this is the introduction to Pythagorean theorem, and you're going to be using this more and more and more as math goes on. So we just need to understand just the basics. So we don't have a lot of homework on this one, but we do need to understand what the sides are. Our two legs, the A and B, make up our right angle. We have to know that the hypotenuse is the C, which is directly across from that right angle. And we have to be able to find what that hypotenuse would be. So you're going to do the last one on your own and the bottom one. The bottom one is a word problem that gives us a right angle. A rope is fastened to a tree. So here's my tree. And we have a rope that's fastened to it 8 feet from the ground. So the tree is 8 feet from the ground where that rope is fastened, tied around. So we know from here to here is 8 feet. So this line is 8 feet. And a stake that is 6 feet away from the tree. So bottom of the tree, stake to the ground is 6 feet. How long is the rope? The rope goes here. This, my friends, is a right angle at the bottom of the tree. So we're taking our word problem and turning it into that right angle. And we know 2 of the legs because we drew it. So when you have word problems with the Pythagorean theorem, you have to draw out your picture so you can see what the 2 legs are. So for my friends in the back, my apologies, I drew a tree. I knew that there was a rope attached going down to the ground. I know that the bottom of the tree to where that rope is attached, they said is 8 feet. I know that from where the bottom of the tree is to where that rope is staked into the ground is 6 feet. I know that this is a right angle at the bottom of the tree. So when you get word problems, nobody should be closing up their book. I am still explaining things. We are respectful listeners, not doing other stuff, respectfully listening. Patience. So you will have a word problem on the test. You do need to know how to put those words into a picture. I do expect to see your picture to make sure that you know where your 2 legs are and how to find the hypotenuse. Okay, you have to be able to translate that. We are not packing up while the teacher is talking. That is rude. This month we are working on respecting the person who's talking. So that means even though you worked ahead and finished while I was explaining things, you're still and quiet. If you are watching this at home and you have any questions, make sure you come ask me. I hope you're well and hope to see you soon. Have a wonderful day.